Okay, we're going to be graphing a trig function that has all four transformations on it. This is example 3 in the packet, but I've actually added a amplitude change on this one so that you can see that as well. Okay, so the first thing that we do is we calculate the period. The period is equal to 2 pi over b. In this problem, b is equal to 2. So we have 2 pi over 2, which reduces to pi. The next thing you do is you calculate your interval. The interval is equal to your period times 1/4, so in this case it's pi times 1/4, which is pi over 4. After that, you find your start. The way you find the start is you set what's inside the parentheses equal to 0, and you solve for x. So in this problem, we're going to be starting at negative pi over 2. Now we're going to calculate our key points. We need 8 key points in addition to our start. So the way the key points are calculated, you start by taking your start plus your interval. In this case, our start is negative pi over 2. Our interval is pi over 4. In order to add two fractions, you need to have a common denominator. So my common denominator will be 4. So I'm going to take negative pi over 2, multiply top and bottom by 2. That's going to give me negative 2 pi over 4. And I add my interval, which is pi over 4. So that gives me negative 2 pi over 4 plus pi over 4 is negative pi over 4. I add my interval to that point. My interval is pi over 4. That gives me 0. So unlike many of the other examples, 0 is actually a key point. So we will actually be putting a dot on the real y-axis. All right, so here's one key point. Here's 2. I'm going to need a total of 8. So I'm just going to keep adding my interval, which is pi over 4. So my next key point is pi over 4. Then I add pi over 4 to that. I get 2 pi over 4, which reduces to pi over 2. I keep adding pi over 4. So that gives me 3 pi over 4. So right now I have 1, 2, 3, 4, 5. I need 3 more. So if I'm just adding pi over 4, the next one will be 4 pi over 4, which is pi. Then 5 pi over 4. Then 6 pi over 4, which would reduce to 3 pi over 2. So I have my start plus 1, 2, 3, 4, 5, 6, 7, 8 key points. Now when we go to graph this, you want to check and see if you're changing from negative to positive. You need to make sure you give yourself enough room on the graph to do that. So here I have a negative pi over 2, I have a negative pi over 4, and then I have a 0. So I have 2 points to the left of the real y-axis. So I'm going to go ahead and make sure I'm going to go back. I'm going to put negative pi over 4 right here, and then I'll put negative pi over 2 right there. So then 0 is a key point, so I'm going to label it. Then pi over 4. And then the next key point after that is pi over 2. The next key point after that is 3 pi over 4. Then we have pi. Then we have 5 pi over 4. And then we have 3 pi over 2. So now when I graph this, I need to look for my vertical translation, which is a negative 1. So negative 1. And then from there I need to go down 4 to negative 5. And I need to go up 4 to 3. Because negative 1 plus 4 is 3. Negative 1 minus 4 is negative 5. All right, now I can graph this. My scaling is going to be a little bit off because of this negative 1, how far away I put it. But I was out of room, so that's how it's going to be for this one. A cosine graph starts at a maximum, so I'm going to put on the new y-axis, that's where you put your first dot. And since it's cosine curve, it's going to be at the maximum. My next key point should be in middle. The next one, because 0 is a key point, I get to put a dot on the real y-axis. That doesn't usually happen. Then I'm going to go back to the middle at pi over 4, and then go up to pi over 2, which is the maximum, back down at 3 pi over 4, minimum at pi, middle at 5 pi over 4, and maximum at 3 pi over 2. So now I can go ahead and connect the dots, and there is my cosine function. Okay, now the next section of the notes is for problems 7 and 8 on tonight's homework. Basically what happens is when you have a negative inside the parentheses, or a negative b for the equation, for a sine curve, it turns out that the sine of negative x is equal to negative sine of x. For a cosine curve, that negative on the inside doesn't affect it at all, so it's the same as the cosine of x. And the reason for that comes from the unit circle. Let's say we have a 30-degree angle. The coordinates there would have been root 3 over 2.5. For a negative angle, we would have negative 30. The coordinates there are root 3 over 2 and negative 1/2. So if you look at the cosine, the x-coordinates are the same for either a positive or a negative angle. But when you take a sine of a positive angle compared to the sine of the negative angle, they change in the algebraic sign. So one is positive and one is negative. So basically what that means for your homework is if it's a sine and there's a negative, you would bring the negative out in front. So this one would have been negative 3 sine of 2x. These are equivalent. If I had given you y equals negative 3 sine of negative x, again, you take the negative out front, and so then that would have been equivalent to writing a positive 3 sine of x. So this one, it's a cosine function, so you can completely ignore the fact that the negative is even in the parentheses. So that would be equivalent to 3 cosine 2x. Similarly, if you had negative 3 cosine negative 2x, you can just ignore that the negative was even in there, and so that's just going to be equal to negative 3 cosine of 2x. Okay, so the negative that was out in front stays out in front, and the one in the middle just goes away.